Okay, and how do I know which interfaces in my network are critical?
I think this question is referring to the network analyzer product. So let's look at that. When you look at the network analyzer views of the network, you have different views that you can use. So this is just one of the views. It shows connection graph, but you have also different views that really map the physical interfaces, or these are not even physical because it could still be a virtual interface, but the MAC addresses and the IP addresses together. And also when you're actually monitoring those interfaces on physical span ports on the routers, you will get even more details on each one of those interfaces, for example, where its port it actually physically came from. And having that detail added to the visual graph will actually show even more details on the actual physical connectivity. But in today's world, with lots of virtual hosts in different environments, the requirement for the actual physical identification is becoming less and less. So for example, if you have a standard EC even, you could easily have several physical interfaces connected to a virtual host running inside. So that actually becomes extremely hard to visualize on the logical layer, and especially in those cases, visual network analyzers is like godsend in that sense, that they can visualize the complexity of the network and not just the physical network, because physical network is much easier to map even with the traditional techniques, mapping the real network and all the traffic between logical interfaces and logical IP addresses and MAC addresses. That's where the chaos becomes nowadays. Seeing where each host is and whether, for example, some of your, like in enterprise environment, you could easily have one of your workers running several virtual hosts behind one physical address. And detecting those is very hard sometimes to do on the physical layer, but very easy to do in the traffic-based network analysis. So there is no simple answer to that. The different views can map logical entities to on different protocol layers together, and you can see a lot of different visualizations. If you go to our website and click on the network analyzer, you have lots of different screenshots and different visualizations which you might find helpful in explaining that further. But I hope that helped at least a little bit.
Okay, thank you. And if you want to specify your questions, please send an email. So, and question, how do you prioritize between fixing different bugs?
When you use model-based tools, the fuzzing tools automatically will identify the vulnerability categories, the exploitation, easiness, and they will, at least our tools will automatically build you different industry standard risk assessment metrics, so that even if you find hundreds and hundreds of zero-day weaknesses, you will get them easily prioritized based on how easy they are to exploit, how potential they are to exploit, and how exposed they are. So for example, if exploiting a weakness requires that you authenticate yourself first, it will lower down those threat metrics. And in addition to using those industry standards, we also have introduced our own risk assessment metric, which is maybe a bit more tailored towards fuzz testing. But anyways, you will find those in all of our tools. So when you run the tools, and if you find a lot of mistakes, you can automatically prioritize those weaknesses and find out which ones are most critical to fix first.
And now it's time for our last question. Are there problems with false positives and false negatives in fuzzing?
So the most interesting difference between fuzzing is that it typically never has false positives. So if a test case crashes something, it really does crash it, and it's very difficult to explain that away. If it crashes with something that you send over the network, then it's an issue. The bigger problem with fuzzers is false negatives, so that if you don't use the correct monitoring techniques, you might miss some of the weaknesses. So for example, running fuzzing against a web server farm, you can send thousands and thousands of test cases per second, and you will always get a response from the web server. Even if there's processes crashing and dying and threads becoming corrupt, the test target will still function like nothing happened. Unless you can go into the host itself and monitor all those different log files and exceptions thrown in the host, you will never catch those weaknesses. So we have an extensive instrumentation library that we can provide, and so if you have any challenges in detecting those weaknesses, then support at codenomicon.com is definitely first place to start with. The other problem with some fuzzers, and also with some setups where our customers are using our fuzzers, where they run hundreds of fuzzers in parallel against the same test target. So in those cases, if one of those fuzzers crashes the product, all those 100 fuzzers will think that it was them that actually crashed the product. So only in those parallel setups where you have multi-processes, multi-threaded fuzzers testing against the same target, there you can have some false positives as well. But typical fuzzing process happens sequentially, so that you don't get any false positives, but can easily and quickly go into fixing the actual problems. So typically fuzzing doesn't have false positives, but in some special cases, yes.
Okay, thank you. This concludes our Codenomicon Fuzzing 101 webcast on zero-day vulnerability management. If you have any further questions, please send them to info@codenomicon.com or to Ari directly at ari.takanen@codenomicon.com. Thank you very much for attending.